Hi class, trying to record this video for our test review on our delayed opening on Tuesday. Got my Duke hat on because my hair's not looking that good yet, but let's get started. So the first page of our review has to do with function operations, and as I've told you before, they always give us a function table. And so all of the operations 1 through 6 are asking us to use those functions f, g, and h. The first one asks us to add functions f and g. Remember, a lot of times you will see it on assessments as this, but it means the same thing. Take f exactly the way it is and add to it g. Remember, there are no sign changes in addition, and so you're just combining like terms. X squared is by itself. I'll change the color. So we're done with x squared. Negative 7x minus 1x is negative 8x. And then 2 plus 4 is 6. On to number 2 with subtraction. You must remember that you must change signs for the second function. So f is negative 7x plus 2 minus, in parentheses, the h function, which is x squared plus 6x. Changing the signs for the second function makes it negative x squared and negative 6x. Combining like terms, negative x squared is by itself. Negative 7x plus negative 6x is negative 13x. And at the end, positive 2. The dot in the middle of 3 tells us that we're going to be multiplying functions f and h. Change colors again if I can. And looks like we're going to have to use FOIL. So it's going to be negative 7x plus 2 times x squared plus 6x. If I'm doing FOIL, I'm doing the first two terms. That's negative 7x times x squared is negative 7x cubed. Negative 7x times 6x is negative 42x squared. 2 times x squared is positive 2x squared. And then 2 times 6x is positive 12x. Combining like terms is negative x cubed, looks like plus 42x squared plus, I'm going to hit pause a second. Okay, sorry about that. It's very hard when you can't read your own handwriting. So negative 42x squared plus 2x squared is negative 40x squared. And then we have plus 12x. And I think that is all of it in simplified standard form. Again, we have now f of x times g of x. Looks to get again like it's going to be FOIL. So it's going to be negative 7x plus 2 times g of x, which is x squared minus x plus 4. You can do it by FOIL or you can do it by box. I'm going to try and see if I can move it down a little bit so we have more room. Just give me a minute. Okay, made myself more room to do box. So remember, you've got a trinomial. You can write that on the top to do all of your multiplication. It's plus 4. And then on the side, negative 7x plus 2. All of the boxes are multiplication. X squared times negative 7x is negative 7x cubed. Negative x times negative 7x is positive 7x squared. Positive 4 times negative 7x is negative 28x. Positive 2 times x squared is 2x squared. Positive 2 times negative x is negative 2x. Positive 2 times positive 4 is positive 8. Combining like terms on the diagonal. 7x cubed 7x squared plus 2x squared is 9x squared. negative 28x plus negative 2x is negative 30x. Oh, I'm correcting, it was positive 9x squared. And then 8 is all by itself, so that is the final answer in standard form for number 4. For number 5, it's g of x minus f of x. In this format, you would see it. And remember, the second term, you must change all the signs because of this negative sign. So if g of x is x squared minus x plus 4, and I'm subtracting f of x, which is negative x plus 2, you're going to use the distributive property to change all the signs. X squared minus x plus 4 plus 7x minus 2. Combining like terms is x squared. Okay, so it's negative x plus 7x makes it positive 6x. That's these two combined. And then positive 4 minus 2 is positive 2. This is the final answer for number 5. Number 6 is addition. Probably going to end up going over into the blue here that you can see. G of x is x squared minus x plus 4. And then adding to that, x squared plus 6x. Final answer is going to be x squared plus x squared is positive 2x squared. Negative 1x plus 6x is positive 5x. And then positive 4 is at the end. That's the final answer for number 6. On to the next page. I don't know if I went too far. Nope, I'm good. All right, for the polynomial, describe the key features. We're doing end behavior. Notice that both ends go down, so this is even negative. If both ends go down, then on the left, as x approaches negative infinity, y or f of x also approaches negative infinity. And on the right, the same thing. As x approaches positive infinity, y or f of x also approaches negative infinity. We notice from the shape that it resembles a parabola. That would make it even. And because it faces down, as we said before, it's a negative leading coefficient. The y-intercept is only going to be 1 point. It looks to me like it is 0, negative 3. The x-intercepts, remember, you can make a list. So I've got negative 5, negative 1, positive 2. For increasing, decreasing, I would always use my highlighter. It says decreasing first, so my function is decreasing here and decreasing here. In order to do that, a good idea is to mark our points or x values where our function has the max and the min. It has a max here at x equal to negative 3 and a min here at 0, and then another, I wouldn't call it a max, but another little hilltop here at 2. So where we are decreasing is between negative 3 and 0, and also decreasing for all x values greater than 2. Increasing starts here at negative infinity. So from negative infinity to to negative 3, I'm increasing, and I am also increasing from 0 to positive 2. The relative minimum occurs at, remember, I only want the y value. So the very lowest point looks like it is at -3. We got that from the y-intercept. And the relative maximum occurs at the highest hill. Remember, I only want the y value. That's going to be 5. For the second one, this picture looks like it is like a line with the right end going towards positive infinity, left end going to negative infinity. So this is going to be odd. This has a positive slope, so it's going to be positive because our arrows match the same as this line. On the left, you can see as x approaches negative infinity, y also approaches negative infinity. F of x is the same as y. On the right, you can see that as x goes to positive infinity, this arrow is up, so the y value, or f of x, goes to positive infinity. Our y-intercept is this 1 point here, which is 0, -1. Our x-intercepts as a list are these points that I'm circling here, and they are -5, -1, and this time +6. Intervals where I am decreasing occur here. And it looks like it's increasing for the rest. Usually what I do is I mark my minimum and maximum. This occurs at -3 again. And this minimum here occurs at +2. So when I'm doing my decreasing interval, it goes from -3 to +2. It increases starting at negative infinity. Oh, that's supposed to be an infinity. That is not supposed to be a -8, negative infinity, and stops increasing at x is -3. It is also increasing starting at +2 and goes until positive infinity. Our minimum is the y value. That's at -2 here. So this point here is +2, -2, but I only want the y value. Our maximum is here. The x value is -3, but the y value is +3.